Starting with the graph of f of x equals 2 raised to the power of x, we want to write the equation of the graph that results from the following. Part A shifts f of x 3 units up, B shifts f of x 4 units right, C reflects f of x about the x-axis, and D reflects f of x about the y-axis. So for a quick review, for vertical shifts, if d is greater than 0, y equals f of x plus d would shift f of x up d units, and if we have y equals f of x minus d, this would shift f of x down d units. So if we consider the basic square root function graphed here in blue, where we have y equals square root x, if we have y equals the square root of x plus 2, notice how the plus 2 is not underneath the square root, this would shift our function up 2 units. And if we have y equals the square root of x minus 2, this would shift the basic square root function down 2 units. So going back to our example, because we want to shift f of x up 3 units, we want y equals f of x plus 3, which means our equation would be y equals 2 raised to the power of x and then plus 3. Next, we want to shift f of x 4 units right. So let's review horizontal shifts of the graph. When c is greater than 0, y equals f of the quantity x plus c shifts f of x left c units. And if we have y equals f of the quantity x minus c, this will shift f of x right c units. So again, looking at the basic parent function here graphed in blue, y equals the square root of x. If we graph y equals the square root of the quantity x plus 2, notice here the plus 2 is under the square root. This would shift the basic function left 2 units. And if we graphed y equals the square root of the quantity x minus 2, this would shift the basic square root function right 2 units. Notice the direction of the horizontal shift might be the opposite of what you were thinking. If we have minus a constant, it's shifted right. If we have plus a constant, it's shifted left. So if we want to shift our function right 4 units, we want y equals f of the quantity x minus 4, which means our equation would be y equals 2. Now we're substituting x minus 4 for x, so we'd have 2 raised to the power of x minus 4. So to enter this into online homework, you do want to be careful. This would be y equals 2 raised to the power of, in parentheses, x minus 4. These parentheses indicate that the exponent is x minus 4. Now we want to reflect f of x across the x-axis and then the y-axis. So for this review, let's take a look at this slide. Again, if we start with the basic square root function graphed here in blue, to reflect f of x across the x-axis, we would let our new function g of x equal the opposite of f of x, or in this case, negative square root x. Notice in this case, we will be changing the sign of the y-coordinates reflecting the graph across the x-axis. If we want to reflect f of x across the y-axis, we would need to change the sign of the x-coordinates. So our new function h of x would be equal to f of negative x, or in this case, the square root of negative x. So again, reflecting across the x-axis, we change the sign of the function values, or y values. When reflecting across the y-axis, we change the sign of the x-coordinates, so we substitute negative x for x. So if we want to reflect across the x-axis, again, our goal is to change the sign of the function values, or y values. So we would have y equals the opposite of f of x, which in our case would be y equals the opposite of 2 raised to the power of x. And then finally, to reflect the graph across the y-axis, we want to change the sign of the x-coordinates. So we would have y equals f of negative x, which in our case would be y equals 2 raised to the power of negative x. Let's go ahead and check this on our graphing calculator. So we're going to press y equals. Let's enter the parent function or basic function into y1. So we'll press 2 raised to the power of x. Now we'll go to the far left by pressing the left arrow. Press enter once. Notice how this is going to graph our parent function bold or with a thick graph. Now we want to go to y2, so let's press the right arrow and then enter. And now we'll make sure this graph would be shifted 3 units up. So we have 2 raised to the power of x and then plus the constant 3. Now to make sure we have the standard window, let's press zoom 6. So there's the parent function, and there's our graph shifted up 3 units. So that's correct. Let's go ahead and check B. So press y equals, go down to y2, and we're going to clear this and enter 2 raised to the power of, in parentheses, x minus 4. This should shift the graph right 4 units. So press graph. Again, there's the parent function or basic function, and there's the graph that's shifted right 4 units. That looks good. Let's go back to y equals. Let's clear out y2, and now we're going to enter negative 2 raised to the power of x. And this should reflect the graph across the x-axis. And notice that it does. And then finally for part D, we're going to go down to y2 and press clear, enter 2 raised to the power of, in parentheses, negative x. Close parenthesis and graph. This should reflect the graph across the y-axis, which it does. So this does verify that our work is correct. I hope you found this explanation helpful.